Since the closing of the Vaux breweries in 1999, a substantial site has been left vacant, prime for an amazing opportunity to develop and repurpose this land as a new urban quarter. As part of the requirements for the Riverside Challenge, 100 new homes shall be built in this area. The focus of the design was to provide a sustainable and efficient solution which would result in low carbon emissions in order to align the design with the UK's carbon neutral targets. The houses have been designed to Passive House standards to help achieve this. Many factors were considered in order to best utilise the Vaux site when designing the urban quarter. Particular thought was given to the layout of the houses in order to maximise the views and natural sunlight to the proposed homes, as well as ensuring sufficient green areas. The open areas serve a multifunctional purpose to provide connected space for residents, as well as creating space for greenery and biodiversity. These spaces will also use the topography of the site to aid with drainage and surface runoff during times of excess precipitation and storms. The public space will promote people's health, happiness and well-being by promoting social activities. The space can be used to meet their neighbours, a space to play, a space to allow people to grow plants and enjoy natural wildlife. Explosion of colour from flowers in the spring and summer could add great character to the site. In addition to this, the flowers also promote birds, bees and butterflies to move in and manage the area naturally. And by reducing the amount of roads, we would create a site which promotes residents to walk and cycle rather than to use their cars, thus reducing the amount of pollution and carbon emission in the area. The landscape is designed so that it can reduce and slow down surface water runoff by soaking up the rain. The water will be taken up by the plants with the objective of slowly being released back into the atmosphere via transpiration. The paved areas in the site will direct the surface water into the soft landscape beds. In addition, there will be French drains implemented where needed to ensure the ground does not become waterlogged near a structure. The SUDS is designed to primarily capture surface water runoff from the adjacent roads and pavements. Its purpose is to clean the water of pollutants and to promote infiltration back down into the soil beneath the evapotranspiration back into the atmosphere. The captured water is used to support the plants in the landscape. The planted areas are formed as shallow bioswales and rain gardens to allow water to flow into them. Both the rain gardens and bioswales can receive runoff water.
The house design is a terrace typology, 6 metres wide by 9 metres long and 3 stories high, with the roof terrace cut into it to ensure that each house has a well-lit, private outdoor area. It is comprised from pre-cut CLT panels, with wall, floor and roof assemblies constructed off-site to Passive House standards. Each CLT element is less than 4.3 metres wide to ensure easy transportation by road. The house plan, overall, places living spaces towards the south, in order to benefit from the increased glazing for better sunlight and views. This is most evident on the bottom floor, where the living area extends from the kitchen on the north side and covers the width of the house on the south, and on the top floor, where the roof terrace is south-facing. 2 bedrooms, one single, one double with ensuite, are on the middle floor, and the primary bedroom is on the top floor facing out towards the terrace. The walls on either side of the stairs are thicker to accommodate space for WC waste pipes. Space for an MVHR unit is located on the north side of the building by the entrance for easy access. Services are routed through voids behind the wall's white plasterboard lining, which also serves as a fire safety measure and helps make the spaces feel brighter. Externally, material choices were influenced by the nearby historic architecture. Victorian red brick terraces in the light-coloured ashlar of Sunderland Magistrates Court and the bronze of the Beam office building. A light-coloured brick cladding and dark roof tile was specified. Internally, the floors and ceilings are finished quite minimally. Exposed screed and CLT echoes the area's maritime past and allows scope for residents to make modifications post-handover. The detailing aims to minimise thermal bridges with extra insulation at joints and also limit the spread of fire within the timber structure by using cavity barriers.
Determining the loading acting on the building will be crucial in designing the structural walls and floor slabs which will keep the building stable and safe to live in. In order to do this, all the loading conditions which we would expect were calculated using the appropriate Eurocode and literature in order to help us simulate what sort of stresses our houses will undergo once constructed. The process of this can be summarised in the flowchart. Self-weight and imposed loads were taken from the Red Book. We then designed our walls and floor slabs to distribute these loads evenly to the exterior walls, which are load-bearing. Loads were taken down from the roof through the exterior walls to provide strong sound insulation between the adjacent houses. To maximise the flexibility and space usage of the house, the interior space is kept free of structural walls apart from the stair module. The following spreadsheet summarises all the loads which are acting on every structural member on each floor and has been accordingly referenced. CLT was chosen as the material due to the ability to easily prefabricate, flexibility during construction, and the high strength compared to self-weight. We exploited the high strength by spanning the CLT slabs across the shorter length of the house, 6 metres. CLT slabs can be easily transported to the site, and the smaller dimensions allow them to fit on the back of a conventional lorry. The slabs will be connected to each other via screwed connections and provide lateral bracing throughout the house. The construction method utilises screws, allowing for easy assembly and disassembly so that the materials can be reused after deconstruction or recycling. All the wall panels can be prefabricated with insulation and space for windows and then transported to site for easy assembly. The design of CLT is covered in Eurocode 5, and we use the guidance from this standard to ensure our walls and floors pass ULS and SLS requirements. As shown in the calculations, the bending, shear, vibrations, etc. all come under acceptable amounts, and so the structure should be safe.
By transferring the loads through the exterior walls, thicker strip foundations can be used between the houses in conjunction with a suspended floor slab. We have used limecrete to reduce the embodied carbon of the design. This will require a careful curing process, but can be easily managed over the large site. The site is made up on made ground above a limestone layer, with a sufficient bearing capacity for strip foundations. We have included ground improvements as part of our design to increase the bearing capacity and decrease the required dimensions of the foundations. The lateral foundations are 0.6 meter wide and 1 meter deep, carrying most of the loading from the slabs. The CLT walls are connected to the strip foundation using metal brackets, which will be underneath the suspended floor slab.
For our costing and procurement, we attempted to keep the suppliers as local as possible and to choose products that were BRE or Passive House certified. The largest cost in the house comes from the CLT shell structure, which will be supplied from KHL at a cost of £64,000. The overall cost of the project, excluding inflation allowance, is £290,000. The cost is relatively high, however it represents the high quality of the materials and design used in the house. Additionally, long-term savings will be seen through the decreased running costs of the house and lower maintenance costs. 3 different sections of CLT are required for the exterior walls, partition walls and for the floors. The CLT from the KHL is FCS C119602 certified. The connections for the CLT have been selected from Rotoplas range of high quality steel brackets and wood screws to support the floor slabs. We have sourced our windows from TRC. The TRC flush casement softwood frame windows are Passive House compliant and have helped us to achieve the target rating. The exterior doors of the house will be acquired from Accoya. The complete key specification and procurement document can be seen on the slide.